nozzle ay siya yung naikot. Tapos yung stationary guide valves, siya para stationary lang, hindi siya nagalaw. Parang ginaguide niya lang yung galing sa moving nozzle. Tapos yung nasa likod, yun yung runner with blades. Yun yung naikot na nakakonekta din sa shaft para umikot yung sa yung shaft na nakakonekta rin sa generator para mag-produce ng electric energy. So power rating. Internal power is the product of torque and rotor speed. Nominal rating is a declared power capacity expected to be the maximum load. Capability is the manufacturer's guaranteed maximum continuous output for a clean turbine operating under specific throttle and exhaust condition with full extraction at any openings. Overload capacity is the difference between capability and rating. So, next. So, computation naman. So, tama ba? Computation sa ideal and actual turbine work. So, turbine work equals mass of steam times H sub 1 minus H sub 2. Tapos, turbine work equals mass of steam times H sub 1 minus H sub 2 A. The turbine work equals turbine work stage efficiency. Turbine power output equals mass of steam times H sub 1 minus H sub 2 times N sub T. N sub T equals NST times N times M ay mechanical efficiency. Generator efficiency naman ay equals to generator output over turbine output. Ang generator output equals mass of steam times H sub 1 minus H sub 2 times N sub T times N sub E. Sa thermal efficiencies, meron tayong brake thermal efficiency. Ang brake thermal efficiency, para makuha ito ay turbine output over mass of steam times H sub 1 minus H sub F2. Combined or overall thermal efficiencies, para makuha ito ay generator output over mass of steam times H sub 1 minus H sub F2. Sa ideal Rankine thermal efficiencies naman ay H sub 1 minus H sub 2 over H sub 1 minus H sub F2. Sa engine efficiencies of turbine, yung para makuha yung brake engine efficiencies ay brake power over mass of steam times H sub 1 minus H sub 2. Combined or overall engine efficiencies ay generator output over mass of steam times H sub 1 minus H sub 2. Next po. So, steam engine. So, steam engine converts the heat energy of steam into work in the form of uh, positive displacement piston cylinder mechanism. So, ang steam engine ay one of the most important invention aspects of the Industrial Revolution. The invention changed and additions to the technology of the time. Isa sa best example dito ay ang steam powered locomotives na ang steam engine ay sabi rin dito ang steam engine ay siya yung nagko-convert ng heat energy ng steam to mechanical energy. So, single acting engine work is done on only one side of the piston having only one working stroke to a revolution. So, one work lang daw yung nagagawa niya every revolution. Double acting engine work is done on both sides of the piston having two working strokes to a revolution. So, one stroke niya ay nakatapos siya ng two works. So, important definition is engine indicator traces the actual PV diagram. Planimeter measures the area of the PV diagram. Dynamometer measures the torque. Tachometer measures the speed of the engine. Next po mga master. So, computation tayo. So, sa volume displacement, piston rod neck double. So, B sub D equals to open bracket, open parenthesis, pi over 4 d square ln piston rod pag yung piston rod considered is pi over 4 d square ln plus pi over 4 times d squared minus d square ln. Indicated power pag kukuha naman yung indicated power is indicated power MEP times VD, volume displacement. So, brake power, kukuha ng brake power, MEP times volume displacement equals Z pi Tn. Sa friction power naman, power indicated minus brake power. So, mechanical efficiencies, brake power over indicated power. Sa thermal efficiencies, indicated thermal efficiencies is equals to indicated power over H sub 1 minus H sub F2 brake thermal efficiencies is equals to brake power over H sub 1, H sub F2. Ideal Rankine thermal efficiencies ay open parenthesis H sub 1 minus H sub 2 over H sub 1 minus H sub F2. So, note po dito ay H sub F2 is equals to H sub 3. Engine efficiencies. Indicated engine efficiency. Pag kukunin yung indicated engine efficiency ay indicated power over H sub 1 minus H sub 2. Sa brake engine efficiency naman ay brake power over H sub 1 minus H sub 2. So, additional information, mean effective pressure expansion ratio ay stroke volume over cutoff. Pag may clearance volume naman, stroke volume plus clearance volume over cutoff plus clearance volume. Sa admission area ay P times cutoff. Sa expansion area naman, P sub 1, V sub 1, ln equals R, ay times R. Expansion ratio. Gross area is equals to expansion area plus admission area. Mean gross pressure ay gross area over length. Sa mean effective pressure naman ay P sub mgp minus PBACK. Sa actual PMEP, para makuha ito ay PMEP times diagram factor. Next po. So, sa condenser, a heat exchanger where steam enters at the top and the condensate is collected in the hot well at the bottom while cooling water flows through the tubes. So, ito daw po ay isang type of heat exchanger na ginagamit natin sa mga steam engine or sa iba pa. So, this function of steam condenser. Convert steam to liquid before entering the steam generating unit. Create a vacuum at turbine exhaust, thereby increasing the turbine power. So, there are two types of condensers. Ito yung surface condenser na where steam and cooling water are not allowed to mix, commonly shell and tube design. So ito yung sinabi dun sa dun sa definition na kanina. So bale yung steam ay free siya, tapos yung cooling nasa parang lalagyan siya. Itong cooling water natin ay nasa tubes. Hindi sila directly na nagko-contact. Tapos pag nagko-condensate siya or nagtuturn siya sa liquid na sa ilalim. Sa direct contact condenser naman ay also called jet condenser where steam and cooling water are allowed to mix. So dito naman nagko-contact na yung steam at cooling water. So tinawag siyang jet kasi yung pag-spray niya ng cooling water. So Yun, ganun din na nangyari. Next po. So, feed water pump whose function is to increase the pressure existing on liquid increments sufficient to the required service. This pumps boiler feed water. So, halos lahat tayo lahat tayo siguro nakakita nito. Gamit to madalas sa bahay o kaya sa mga power plant. Um, so, it, ito yung feed water pump. So, yung example natin dito ay centrifugal pump. So, so merong butas diyan sa H3 na doon napasok yung tubig tapos nalabas sa H sub 4. So, pump work uh, equals M times H sub 4 minus H sub 3 uh, equals M square root of 3 times P sub 4 minus P sub 3. Sa power out input of the pump ay mass of steam times H sub 4 minus H sub 3 over EP. Yun lang po at maraming salamat.
So para sa solar and wind energy, first I am Christian Calvin and I will report this topic. So next page please. Solar energy. Solar energy is the radiation from the sun that is capable of producing heat, causing chemical reaction, or generating electricity. It is the largest source of energy received on Earth, but its intensity on Earth surface is quite low. Also, solar energy is rapidly becoming the ultimate energy source because of its non-polluting character and its inexhaustible supply, which are in stark contrast to such fossil fuel sources as coal, oil, and natural gas. Also, did you know that the Earth intercepts a lot of solar power? That is 174,000 terawatts. That means that it is 10,000 more power than the planet's population. So as you can see that malaki talagang may tutulong ng sun's energy or what we call solar energy. So next slide please. Yan, principles of solar energy. Solar panels are made up of smaller units of solar cells. The most common solar cells are silicon, a semiconductor that is most abundant element on Earth. A crystalline silicon is sandwiched between two conductive layers and silicon atom is connected to its neighborhood. Makikita po natin dito sa left side ng picture na yun nga po, makikita na merong dalawang type na silicon na nakasulat dito po sa right side na nakasandwich po siya. At silicon nakasandwich po siya at sa pagitan po nito ay yung PN junction na i-discuss ko mamaya. So, ang silicon or solar cell ay gumagamit ng two layers of silicon na ginagamit natin katulad nga natin sa kanang picture. An N-type silicon and P-type silicon. N-type silicon has an extra electrons, and P-type electrons has an extra space for electrons called holes. Look at the left photo, and we can see that where the P-type and N-type electron met, the electron can wander across PN junction, the middle part of the solar panel. Excuse me. Blue line that leaving a positive charge on the side and creating negative charge on the other. So when heat energy from the sun strikes the silicon cell without energy, it can knock an electron from its bond and it will leave a hole The negative charge electron and location of the positively charged hole are now free to move around. But they will only go in one way because of the electric field in p-n junction na yung nasa gitna pa. After that, the positive and negative charge are joined by a connector like wire and current of electricity will occur. So next slide please. So to make it simple, katulad ng sinabi ko kanina, para mapadali, when sunlight strikes the solar cell, electrons are knocked out loose from the molecule. They move toward the treated front or surface. An electron imbalance is created between both of the surface of the solar cell. When the two surfaces are joined by a connector like a wire, a current of electricity occurs between the negative and positive side. Uh, Next slide, please. So generation of solar power. Solar power is the conversion of sunlight into electricity, either directly using photovoltaics or what we call PV, or indirectly using concentrated solar power or what we call CSP. So first, what is photovoltaics or PV? Photovoltaics converts light into electric current using photoelectric effect. And we forgot to put the CSP or what we call concentrated solar power. But concentrated solar power produces electricity by using mirrors to concentrate the sunlight into receivers, which produce steam to generate electricity, like the photo in the photo below. So energy storage method. Solar energy can be stored at high temperature using molten salts. Salts are effective storage medium because they are low cost, have a high specific heat capacity, and can deliver heat at temperatures compatible with conventional power system. So in this photo, we can see that the molten salt can be used in solar power generation to store heat until it is needed. So the large mirror focuses the sun rays on the central collection power. The molten salt is heated in the tower, then pumped into storage tank. So next is the heated salt is then pumped through a steam generator. The steam is used to power an electric turbine, and the cold salt is returned to a second storage tank to be sent back through the cycle again. So next slide, please. So solar cell. Okay. Solar cell is also called a photovoltaic cell or photoelectric cell. It is a solid state device that converts the energy of the sunlight directly into electricity by the photovoltaic effect. Uh, assemb- Assemblies of cells are used to make solar modules, also as solar panels. The energy generated from these solar modules referred to as solar power. It's an example of solar energy. Also, a panel is an assembly of photovoltaic cells mounted in framework for installation. Solar panels use sunlight as a source of energy to generate current or electricity. Current electricity. Sorry. Uh, Cells are described as photovoltaic cells when the light source is not necessarily sunlight. These are used for detecting light or other electromagnetic radiation near the visible range, for example, infrared detectors or measurement of light energy. Another note is that 12 photovoltaic cells are enough to charge a cell phone, and it takes a many module to power an entire house. That is just a quick note. So next slide, please. So yeah, Like what I said earlier, that the energy receives 174 petawatts of incoming solar radiation insolation at the upper atmosphere. Solar power system installed in the areas defined by the dark disk could meet world's current total energy demand. So applications of solar technology. Solar technology are broadly characterized as either passive solar or active solar depending on the way they capture, convert and distribute solar energy. So first is let's talk about solar techniques. Solar techniques use photovoltaic panel, pumps and fans to convert sunlight into useful output. And the passive techniques include selecting material with favorable thermal properties, designing spaces that naturally circulates air, and referencing the position of building to the sun. So for the next slide, please. Yeah. So here we are at the pros and cons of the solar energy. So the main pros of the solar panels are it gives off no pollution. Solar energy produces electricity very quietly. Unlike power plants, coal power plants or wind turbines, for example, they are very noisy and it can interrupt other people. So it's nice. Uh, because of its noise, I'm sorry. It has the ability to harness electricity in remote locations that are not linked to a national grid. It is very efficient in large areas of the globe. First, and solar panels can be installed in the top of many rooftops like many other people or households do this. It is affordable in the long run. Uh, it is noted here in the long run because first of all, it is very expensive first, but like what I said earlier, in the long run, it will be what I mean is yung sulit sulit yung panel. So second to the last, it is affordable in I'm sorry. Lastly, the use of solar energy to produce electricity allows the user to become less dependent on the world's fossil fuels. Being less dependent on the world's fossil fuels supplies means that you are gumagamit ka ng less coal on the which is very good for the earth. So solar energy. The concept of the solar energy is first the initial cost of solar cells. Yeah, it's the initial cost of solar cells are very expensive. And second is solar energy. Solar energy is only available to generate electricity during daylight. This means around half of each day, solar panels are not producing energy for your homes. So katulad ng kapag halimbawa ay maulan maghapon, you will not generate electricity or you will very little makatanggap ka lang ng energy or electricity. So the weather can affect efficiency of the solar cell. Pollution can be a con of the solar energy, as the pollution levels can affect a solar cell's efficiency. This would be a major con for the business or industry wishing to install solar panel in the polluted areas such as cities. Para mapadali, ibig sabihin ay pollution since nakaka-apekto siya sa earth, ibig sabihin ay maleles na rin yung nare-receive yung heat source from the sun or solar energy. So for the wind turbine, next page. Wind turbine, before we discuss about the topic, let me give you some introductions. Did you know that every 24 hours, wind energy generates enough kinetic energy to produce roughly 35 times more electricity than humanity use each day? So, for the history of wind energy, Humans have been using wind power for at least 5,500 years to propel sailboats and shipping sails. Windmills have been used for irrigation, pumping, and for milling grain since the 7th century AD in the Afghanistan, India, Iran, and Pakistan. Uh, Wind power is also a renewable energy source used to generate electricity by converting wind energy into mechanical energy. This mechanical energy is then converted into electricity by the use of an electrical generator located within each individual wind machine that we will see the parts later on the presentation. So blowing of winds spins the blade of a wind turbine. This device is called a wind turbine and not a windmill. A windmill grinds or mills grains or is used to pump water. Worldwide, there are now many thousands of wind turbines operating with a total of nameplate capacity of 194,400 megawatts. World wind generation capacity more than quadrupled between 2000 and 2006, doubling about every 3 years. So next slide, please. For the origin of winds, so, the origin of winds may be traced basically to uneven heating of the Earth's surface due to sun. This may lead to circulation of widespread winds on global basis, producing planetary winds, or may have a limited influence in a smaller area to cause local winds. So global or planetary winds. Two major forces determine uh, the speed and direction of wind on global basis. First is primary force due to the differential heating of the Earth at the equatorial and polar region, which is heat transfer. And spinning of the Earth is about its axis produces a Coriolis force, which is responsible for deviation of air currents. Deflects the direction of the winds. Deflect. Yeah. So number two is local wind. Uh, it blow over the short distances. Localized and uneven heating is responsible for local winds. Local winds are produced due to two mechanisms. First is due to differential heating of land surface and water bodies due to solar radiation. Second is due to differential heating of slopes on the hillsides and that of lowlands. Uh, yeah. For next slide, please. Yeah. Here. So how does wind energy work? Wind blows past turbine rotating their blades. The kinetic energy is transformed into mechanical energy. A gearbox spins a generator to produce electricity. A transformer converts the electricity to appropriate voltage, and electricity can be stored or transported to grid for distribution. And after that, we will send to our homes. To make it simple, the wind's kinetic energy to rotational energy to electrical energy. So next slide, please. So here, uh, electricity generation. The blades of the turbine are attached to a hub that is mounted on a turning shaft. The shaft goes through a gear transmission box where the turning speed is increased. The transmissions the transmission of box is attached to a high-speed shaft which turns a generator that makes electricity. To make it simple, makikita po natin. No, we will explain the part later. So next slide, please. So there are two types of, before we go to the hot and hot, I would like to the factors of how much electricity can they produce. First is the size and orientation of the blades. Second is blades aerodynamic design. The bend style of the the turbine or the blade. And the third is the amount of wind turning the rotor. So that is just simple factors. So next is types of wind turbine. The HWAT and VAWT. The HAWT is the horizontal axis wind turbine. The design allows the blades to capture winds full force by tracking wind's direction and turning where the winds comes from. It is also called yawing. And the VAWT or the vertical axis wind turbine blades can be picked up wind from any direction but with less efficiency than the horizontal axis wind turbine. So wind travel faster over the curved surface, creating a low pocket above the blade, forces it upwards. And hot and hot. So next slide, please. Before we go to the wind turbine components, would like to give a note that a turbine can only capture 59.3% of wind's energy. That is according to Albert West. So for the wind turbine components, first is blade. Blades. Most of the turbine have three blades. The turning of the blades generate electricity. Like what I said earlier, that the blades size and the orientation of the blades and the design are also a factor for wind to generate for the turbine to generate electricity by receiving the wind. Second is hub. It's the center of the rotor to which the rotor blades are attached. Rotor blades and on the rotor blades and hub refer together. So and the fourth is low speed shaft. The low speed shaft is on the inside part of the turbine. So low speed shaft turned by the rotor about 30 to 60 rotation per minute or RPM. So gears connects low speed shaft to a high speed shaft and increases the rotational speed from about 30 to 60 rotation per minute about to about 1000 to 1800 rotation per minute. The rotation speed required by most generation to produce electricity. And the generator that produces electricity that from the rotations. High-speed shaft drives generator, controller, starts up and shuts off the machines. Anemometer, it measures the wind speed and transmit wind speed data to controller. Wind vane measures the wind direction and communicates with yaw drive to orient turbine. And yaw drive keeps the rotor facing the wind as the wind direction changes to prevent loss of speed of the wind of the rotation. I mean, yaw motor powers the yaw drive. Nacelle contains gearbox, low and high speed shafts, generator, controller, and the brake. Tower. The tower is made up of tubular steel, concrete, or steel lanterns. Uh, Taller tower generates more power. And pitch. Blades are turned or pitched to control rotor speed, and brake is to stop the rotor emergencies. So the main purpose of the brake usually used in sample for when there is uh, yeah. So next slide, please. So these are the pros and cons of the wind energy. First is renewable energy, like the solar energy. Like all forms of solar energy, wind power systems are non-polluting, so it has no adverse influence on the environment. Like also in the solar energy. And wind energy system avoid fuel combustion and transport cost-free renewable sources. So for the disadvantage of wind energy, wind energy is available fluctuating in nature and it varies from zero to storm force, which is unreliable. Uh, Second, this wind energy system are noisy in operation, like what I said earlier. A large unit can be heard many kilometers away. So it is also it is like other power plants that requires the the houses should be uh, far away from the wind turbines. Birds and bats have been killed by flying into rotors, so animals can be affected too. Good wind sites are often located in remote locations, far from the cities where electricity is needed. Installation and maintenance cost of wind turbine is very high because it is very expensive. So that's it for our presentation. Uh, I hope you learned some things about our topic. Thank you.